Hey guys, this is 4.1 part 1. We are starting unit 4 and we're talking about linear functions in this video. So a function f is a linear function if for real numbers a and b, f of x equals ax plus b. So it can be written in this standard form, which is basically just y equals mx plus b that you've seen a million times over. So you know that b is your y-intercept, or you could call it the starting value of the function. So when you input x equals 0, it's going to be that initial value. And then a is the constant rate of change, or the slope of the function. And of course, the y-intercept is 0, b. So we've seen this a million times. You had a y instead of f of x, and then you had an m instead of a, but it is the same thing. So that m is still your slope, which another name for that is the rate of change. And then the b is still your y-intercept. Another name for that is it's the starting value of the function. Now let's talk a little bit about slope. So slope can be described as the rate of change, because slope is exactly that. It's how quickly something is changing. So you could say it's how quickly the distance is changing in terms of time, how quickly the volume is changing in terms of height, how quickly the height of, say, a kid is changing over time as well. So just lots of different ways slope can be used practically, and it is a rate of change. It's how quickly something is changing. So we know the slope formula, and we typically do use that m there. M equals the change in the input over the change in the output. So you're putting something in, that's your x values. Oops. And you're getting something out, that's your y values. So you've got your output on top, your input on bottom. And then that's the same thing as delta y, delta x. What that literally means is the change. Delta means change. So that's the change in y over the change in x. So change in y divided by change in x, or you could simply subtract y2 minus y1 over x2 minus x1 if you are given 2 points, if you're given information for that. Now note that the function, that function notation is y1 is the same thing as f of x1. So if I plug in x1, I get out y1. So you can use f of x1 in place of the y2, f of x2 in place of y2, and then f of x1 in place of y1, and that's the same thing. That notation means the same thing as y2 minus y1 over x2 minus x1. So it can be written either way. So basically, if you're given those two y values, cool, y2 minus y1 over x2 minus x1. If you have the function, you may need to find those two values, and that would be f of x2 and f of x1. When you input an x value, you get out the y value, and that is f of x2, f of x1. All right. Let's look at some examples. If f of x is a linear function, and 2, 3, and 0, 4 are points on the line, find the slope. Is the function increasing or decreasing? So m equals, and so I can say x1, y1, x2, y2. So I will do just plugging this in to y2 minus y1 over x2 minus x1. I've got 4 minus 3 over 0 minus 2. So that's 1 over negative 2, which is the same thing as negative 1/2. You don't really want to leave that negative in the denominator. You can just bring it in front of the fraction or to the numerator. All right, so is the slope, this is the slope, and then it says, is the function increasing or decreasing? If you have a positive slope, your function is increasing. If you have a negative slope, your function is decreasing. As x gets larger, y is going to get smaller because we have that negative slope. So for this one, it's going to be decreasing. The population of a small town increased from 1,442 to 1,868 between 2009 and 2012. Find the change of population per year if we assume the change was constant from 2009 to 2012. All right, so we're going to do the change in population per year. So that means I have population over years. So that means my population is going to be my y, and my year is going to be my x. Typically, time is the x value. You're seeing how something changed in terms of time. So let's see. If you want to write these as ordered pairs, those 2 points that you have, remember the year is going to be your x value. So 2009 is going to be 1,442. And then 2012 is going to be 1,868. And then from there, we can say this is x1, y1, x2, y2, and plug it into the slope formula. Because we are looking for, let's see what they say, find the change. So that's going to be the rate of change, which is the slope. So we're going to do 1,868 minus 1,442 population, change in population over the change in time, 2012 minus 2009. All right, so you can use your calculator. 1868 minus 1442, so 426, and then 2012 minus 2009 is 3, so I can just divide that number by 3, and I see the the change in population per year is 142 people, so 142 people per year. All right, recall that lines that are parallel have the same slope, right? They're parallel, they're moving in the exact same direction, and that would be the same slope. And lines that are perpendicular have slopes that are opposite, or you could say negative reciprocals. We've already talked about that this year. So basically opposite, you're changing the sign, and then reciprocals, you're flipping the fraction. Even if it starts out as a whole number, it will become a fraction. Okay, so just a little reminder about that. And then we will continue these notes in the part 2 video.